Hey dear all, welcome to Hydrograph analysis. Okay, I just briefly explain what is the hydrograph. Okay, I think I explained this figure before. Alright, so I don't like to explain more it. I just want to explain how to draw or how to plot the hydrograph. Okay, so hydrograph analysis. Actually, we in this topic will discuss the unit hydrograph derivation and application of unit hydrograph. Okay, so meaning that we will derive unit hydrograph and then we will analyze unit hydrograph, what are the different applications and uses. So how we draw unit hydrograph or hydrograph actually complete. Actually hydrograph is a combination of rainfall and stream flow, meaning that when we have a rain, so this rain produces runoff in the watershed that we know. Okay, so in this figure you can see that this is the runoff, this is the rainfall pattern, means the rainfall occurred sometimes and the rainfall different time. These are the rainfall um, depth different time. So rain started at this time, rain is maximum, and due to this rain, so in the river we observe this hydrograph. Okay, so how we derive this one? This hydrograph from the rainfall. Okay, so that is the topic today. So I have already explained what is the unit hydrograph and everything. So I just give you another explanation how we can draw the unit hydrograph so that you will not be confused again. Okay, so here is, you can see, just look the this plot first. In this plot, what we have the x-axis, this is the x-axis, and this is the y-axis. So x-axis is the time. Okay, x-axis is the time. So you can consider this time as a stream flow observation time. Okay, meaning that you had a watershed like this. So rain occurred in this watershed, and somewhere at the downstream we observed. Okay, so we observed what? T and Q. Okay, T and Q. So this x-axis actually the time that we observed at the river. So it can be in every hour, it can be every 5 minutes, it can be every 10 minutes. It depends how we observe the data. Okay, I hope very clear. And the Q is the stream flow. Okay, so what is the rainfall then? So this is the rainfall occurs, and it says here 2-hour unit hydrograph. Okay, so how we define 2-hour? 2-hour here is the rainfall duration was 2 hours. Okay, rainfall duration. The rainfall, it was 2 hours. Okay, so be very careful. When you say 2 hours, this is the rainfall duration. But these 2 hours and this time is not the same. This time can be any duration, any interval. It can be it can be plotted by 5 minutes. It can be plotted by 10 minutes. Like rain occurs in this watershed for 2 hours. This is called 2 hour. But this Q at the outlet, we can observe every 5 minutes. We can observe every 10 minutes. We can observe every 1 hour. So how we observe? We plot accordingly. So in this plot, it was observed every hour. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the so be very uh, clear, the duration this 2 hours and this time is not the same. But when you said the 2 hours, so we can identify where is the 2 hours. So this 2 hours means this is x-axis is every 1 hour. So 1 hour, 2 hours. Okay. So now we can. So this is the 2 hours. This is a blue one. This 2 hour is this duration. So this is the way we show 2 hour in Hydrograph. Okay, I hope clear. If not unit hydrograph, just a simple hydrograph. Simple hydrograph means this T and Q. So then is the same. That time the unit will not be here. Okay, just plot. Just if we plot the T and Q only. Okay, this one is after derivation of unit hydrograph. So I will show the example now. But before this, I will explain how to derive the unit hydrograph, the theory. Okay. So this is I have already explained before. Okay. So this is the rainfall. So this rainfall generated the steam flow, and this is the peak. Okay. This is the hydrograph. So when we want to derive unit hydrograph, we need a rainfall and steam flow. Then we can produce the complete hydrograph. But when you produce the unit hydrograph, so rainfall is not necessary. We can derive only from steam flow. Okay, but we needed some other information like watershed information and other things. Okay, so that step I have explained in the class. We have only 4 steps. First step, we separate the base flow. Second step, compute direct runoff. This direct runoff means the water that comes to the river, it is visible, means we can touch it. This is called direct runoff, not the water under the soil. Okay, because during the runoff process there are some water penetrate into the soil, means in the underground or subsurface water. So that is not direct runoff, that is a base flow. This is the component of base flow. All right. So direct runoff, complete direct runoff. This direct runoff means the amount of water we can see in the river, means how much water river hold or how much water is flowing in the river. That is the direct runoff. So the complete runoff depth. So complete runoff depth, this is called excess rainfall, because the runoff that produces it is from the excess rainfall. So rain occurs on the watershed, then some interception, infiltration, after the evaporation or evapotranspiration, all the process is losses. So after this, the remaining or excess water comes to the river. That is called runoff, and this runoff produces from excess rainfall. All right. Then we can calculate the depth, and then we will check, because I mentioned that unit hydrograph is the hydrograph. Okay, like this. This is the unit hydrograph. So this is the total hydrograph. So then we can separate the base flow. This is the base flow part. So after separating, this is the runoff, means direct runoff. So once we produce the unit hydrograph, so this is the unit hydrograph, and we told that this unit hydrograph is actually for 1 centimeter. Okay, or 1 inch. 1 inch. But we will not follow imperial units, so we'll use 1 centimeter. All right. So these are same 4 steps. Step 1, step 2, step 3, step 4. Okay. So here is the example. I explain this one first in the PowerPoint because in the Excel I cannot write. All right. So first understand the questions. What are the given in the questions? You can see here. This table given observed discharge 6 hours intervals. When you say observed discharge, meaning that this is the watershed, rain occurs here, and somewhere at the downstream, this is the station where we observed. How we observe? Every 6 hours. So this is means T and Q. Okay. So this is the observation. So this is the column 1, column 2. Okay. This is the 6 hours interval. This is here showing 6 hours interval. You can see here. So this observation you can do every 1 hour, every 30 minutes, every 2 hours, any time. So this observation we can do for any time. All right. This is depends on the users or hydrologist how they observe here. We can do every 2 minutes, every 5 minutes, every 10 minutes, every. So this is called just a interval how we recorded the data. This is called observed discharge. So this observed discharge, this interval we put in this column, in the first column. Okay. And how we observed, this is the data. Okay, Q at this point. From an isolated storm is the some rainfall for 3 hours. So meaning that this watershed, there was a rainfall. That rainfall was 3 hours. 3 hours rainfall in this watershed here. So this is 3 hours rainfall. So this is called rainfall duration. Rainfall duration. Okay. Rainfall duration. So this rainfall duration and this time is not the same. Rainfall duration is a fixed. It is 3 hours, 3 hours. But observed Q and in the at the river side, this can be any time. All right, as I mentioned before. And then the drainage area. Drainage area means the watershed. Means this is the watershed. So this watershed is 300 kilometers square. Okay. So one thing is we just need to know some conversion. 1 kilometer square equals 100 hectare, and 1 hectare equals 10,000 meter square. Please remember this. Okay. Assume a constant base flow. So base flow here is 17 meter cube, just a constant. Okay. And before I mention how you assume the base flow, okay, in the class. So in that case, I explain again. Sometimes, let's say this is the stream flow. This is the stream flow. Let's say it is not. It is 17, but here is, let's say, 20. So in that case, I recommend you to consider the base flow is not 17, just consider 20. Okay. The main purpose of this is when we when we when we subtract 20 from this Q, column 2. Okay, column 2 minus the column 3 means base flow. So the first value and the last value here should be the 0. That's the purpose. That's why we put the 20. So if we put 20 means 17 minus 20, it is a minus 3. So minus 3 is a 0. Okay. Anything is less than 0 is 0. So this is the purpose. Okay. I hope it is clear. And then the first thing is uh, then okay, this is the thing, and then asking the question, derive theory or unit hydrograph. So first I will explain you how to derive unit hydrograph for the same duration. Same duration means the rainfall was 3 hours. Okay, rainfall, rainfall 3 hours. So we produce the unit hydrograph 3 hours, same duration. So to derive unit hydrograph, what we need then? We need just hydrograph. Okay, we need a hydrograph. All right. So what is the hydrograph? The main input is hydrograph. Hydrograph. So hydrograph is most of the cases it is easy to find, easy to get. Okay, because normally our DID, the DID, or we call JPS. So this DID and JPS, they actually collect. There are many river station. There are river station. Okay, so there are different places. They collect the Q with the T and Q. So they collect normally every hour, I don't know, every 5 minutes, 10 minutes, 20 minutes. They have some what called automated station. So like IoT. So the sensor device, flow meter or water level is there. So they transmit the data direct to their office. Okay, so they can collect every minute, no problem. But finally they compile the data for daily. Okay, but if you request for 10 minutes or 30 minutes or 1 hour, I think they can provide it. All right. So this is we need only hydrograph. So hydrograph actually simply the time and river flow that we observe in the river. Okay, so once we have this data like this column 1 and 2, okay, this part, this is the hydrograph, time versus q. So hydrograph is simply at anywhere in the river when you monitor river flow with the time, so meaning the time and q. So at any time, any interval, any time interval, it can be every minute, it can be 5 minutes, it can be 10 minutes, it can be 30 minutes, 1 hour, 6 hours, whatever. So that is called hydrograph. So once we have this hydrograph and our watershed information means how is the watershed area. So this how is the watershed area, now you know how to derive the watershed. Is it you need a DM, then you can delineate the hydrograph using QGIS, ArcGIS, you can do it. All right. So this stream flow, now we can derive the unit hydrograph. As I mentioned before, first we derive rainfall duration 3 hours, we derive same duration unit hydrograph. Okay. All right. So meaning that we derive unit hydrograph from stream flow, or we call hydrograph. So once we have the hydrograph, from this hydrograph we can derive the unit hydrograph. So how we can do it? Just look it. Okay. Now I will show you. Okay. Some how to do it. It is very simple. As I mentioned, let's say I just want to change it, because in that case this is the hydrograph is given, this is the observed data T versus Q. So this observed data was every 6 hour intervals, but in this case it is mentioned 17 and 17 is the same, so base flow is 17, it's fine. But if let's say if it is that I mentioned it is 20, so assume base flow 20, that make it 0. Okay, this is the thing. So we stick to this example. So this is the stream flow, so this data will be given, this is blue text. So base flow is 17. If base flow is not given, you have to assume based on the first value and second value, last value, which one is the highest. If first value is 17, second value, last value is 20, so consider 20. Alright. So once you consider the base flow, next step is calculate the direct runoff. So direct runoff is simply this one, column 4. So it is just column 2 minus column 3. Okay, so meaning that stream flow minus base flow. This is direct runoff. Okay, so this is done. So now we have to produce 3-hour unit hydrograph. So to produce the 3-hour unit hydrograph, we need to do something. What we have to do? So this is the flow. You can see this is the, and this is the total flow. So this is the meter cube per second. So this meter cube per second we convert to volume. Okay, 970 meter cube per second. So this one we will convert to volume. How to convert volume? So simply multiply by this interval. How we observed interval. So meaning that 6, 12, 6 hours. 12, 8, 6 hours. So 6 hours. So this is, we have to, this is hours, so convert to second. So we can get, so second cut. So this will give you the meter cube, some value. It is a big values. So once we have the volume, then we can calculate the depth of water or depth of rainfall. That is actually volume divided by watershed area. So watershed area is given 300 kilometers square. So this 300 kilometers square, so watershed, because this is the meter cube, so we have to convert this one into meter square. So how to convert? As I mentioned before, so 300 kilometers square, I told you 1 kilometers equals to 100 hectare, and 1 hectare equals to 10,000 meters square. So 300 multiply 100 multiply 10,000 meters square. So this is meter square. So this one will be here. So now we have a V. Now we have a watershed area. So this is the meter cube, and this is meter square. So we can get the meter. So then convert to centimeter. Okay. Equal to centimeter or convert to millimeter. Okay. So that is we have done here. Okay. So that is I explained details, but you can use this formula that D I mentioned in before. D I mentioned here. This is the calculation, but if you can use this formula, this is 0.36. 36 comes from where? Because 1 hour equals 3 second, is it? 3600 second. So this is a 0.36. It is a conversion factor. So in that case, 0.36, and T is in hour. A is the watershed area, 300. And the summation of unit hydrograph is this one. Summation of, it can be summation of direct runoff or summation of unit hydrograph. Okay. So both cases. So first we will use the summation of direct runoff. You can see when you use summation of direct runoff, then we can get the excess rainfall. Okay, this is the excess. So we can compute the excess rainfall. So 6.98, then we can get the excess means excess rainfall. That rainfall produces runoff. So this 6.98 now we can. This is the direct runoff. So now 103 divided by 6.98. So we can get the, this is the Q. So this is the ordinate, this is the ordinate, it's called unit hydrograph. Unit hydrograph means the stream flow for 1 centimeter, but this one is stream flow for total rainfall. Total rainfall is, how much the total rainfall? It was 6.98. So if rainfall is 6.9, if rainfall is 6.98 centimeter, and this is the time in stream flow, so for 1 centimeter it is just simply divided. So this is the division. So then we can get the 3 hours unit hydrogram. All right. So this is the thing. But when we do the checking whether it is correct or not, we use the same formula, 0.36 TA. But when you do the summation of unit, in that case we will use this one, total unit hydrograph. So when you use the unit hydrograph and if you use the same formula, the answer will be 1. So meaning that this unit hydrograph is for 1 centimeter. So meaning that this part is from 1 centimeter. So when you use this one in the formula, okay, here, this formula. After this, we can find, okay, this is the 1 centimeter. So this is okay. So this is called checking whether unit hydrograph derivation is correct. We can find it. After this, we just plot. We just plot the, this is the total hydrograph. This is the unit hydrograph. Okay. So this is the plotting. So plotting is column 1, and this one, and last column. So column 1 and the direct runoff and unit hydrograph, we plot together. When we plot together, then we can find the total hydrograph, also find the unit hydrograph. So this is the explanation how we deduct the unit hydrograph. All right. So now look at how we do it in the Excel bucket. Okay, because during the Excel I cannot write because there is some problem with me here. So but I can show you. I fit it, otherwise it will cut, because the video will be generated only within this area. Okay, so fit it here. Okay, so here I like to show you the different example. Okay, but we can change it. I will share the Excel, you can play with this. So in the PowerPoint slide I showed you, observed is 6 hours, is it? Not 1 hour. But here is observed interval is 1 hour. Okay, but rainfall duration is 3 hours. So if you choose here 6 hours, I will show you later. Just I explain this one first. So this is the hydrograph observed every 1 hour. So this is the steepness. So this is the hydrograph, and here is a 20, here is 17. So I considered base flow 20, although in the question, because I didn't change here. Okay, so let's say 20. Okay, so once we make 20, so next step is column 2 minus column 3. Okay, so once we subtract column 3 from column 2, this gives you the direct runoff. After this you do the summation here. Summation, actually the same data, I think the same data, but I just changed to 1 hour. Okay, observation time is 1 hour. So what will happen then? So this is the direct runoff. Okay, direct runoff. So what you have to do, and watershed is 300 kilometers square, storm duration is 3 hours, it's fine. Okay, so meaning that we will produce here 3 hours unit hydrograph. So this is the formula that I mentioned before. You can use this formula. Okay, if first now we have to calculate the effective rainfall. So you can go both, or either you can use this formula direct, otherwise you can use this uh, calculation that I mentioned. You can calculate the volume first, then volume divided by area. So this is the volume, how we determine. This is volume, how to calculate volume. Volume is this amount, 937 means total direct runoff multiplied by the time, duration, this duration. Okay, duration means the observed interval, observed time. So it is 1 hour, is it? 1 hour. So this is the volume. Okay. So here is the duration is 1 hour, but I can change here to this one. I mentioned here this one A312 so that you can understand that this is the thing. But you can take from direct from here like this. Okay, is the same. Okay, so now it is here. But this one comes from here. Okay, alright. This 1 hour is from here. Okay, so now this is the volume. Once we have the volume, then next we can determine the effective rainfall. Effective rainfall, or sometimes we call excess rainfall. Whatever you can write, no problem, same. So effective rainfall is this volume divided by watershed area. You can see here watershed area 300 kilometers square. Okay, so simply we can do it. Okay, but you can use this formula. You can see here 0.36 D24 is the D24 is uh, D24 is the D24 is the 937 means summation of this DIO, and then the time is Z26. This is the Z26, this time T. In this case is 1 hour difference, and A is the watershed areas. So you can find the excess or effective rainfall. In the PowerPoint slide, when it was 6 hours, it was 6 point something. But when ordinate is interval is 1 hour, it is 1.2. So now next step is what to do. So next step is, this is the direct runoff. So just this amount divided by 1.2. This one. Okay. This amount. This is the direct runoff. This direct runoff. So this one. This is the direct runoff. So this one is divided by 1.2. So then we can find the unit hydrograph. So this is a pink one is not important now. This one is different. This one I will explain later. This was, I just showed that once we have the unit hydrograph. So this one means the hydrograph for 1 centimeter. So once we have this one, so we can produce the hydrograph for any amount of rainfall. It can be 5.5, it can be 4.5, it can be 3. Just multiply this. So in this case, I just showed one example. So if we have the unit hydrograph for 1 centimeter, then what is the stream flow for 5.5 centimeters? So just multiply by 5.5. This, just multiply column 5 with 5.5. Okay, so if we have a, let's say, what is the stream flow for 4 centimeter, 4 centimeter stream flow, then what we have to do? We have a unit hydrograph, just multiply by 4. That's so this is the stream flow for, so if rainfall occurs 4 centimeter in the watershed. So this is the one good application of unit hydrograph. So when you have a unit hydrograph, which we derived before in the watershed. So next day or next time, in the future time, any amount of rainfall, if we have a one rain gauge in the watershed, if I know what is the rainfall, just multiply by the rainfall, we can find. Okay, just include. This is the thing, very useful. Okay, so then next one is the checking. I told you the checking, you can use the same formula, only the summation of direct runoff. Instead of summation of direct runoff, we use the instead of unit hydrograph. So meaning that this one, you can see here, this one, other is same. Once we do, we get the 1 centimeter. So meaning that this is the correct one. So next, we can plot. What to plot? First, we can plot this. You can see on. First, we can plot this one and this one, or we can plot this stream flow. Sorry, this the ordinate means time, observed time, and we can put the direct runoff like this one. 3 hour. This is a unit hydrograph. This is the direct runoff. Okay. So in that case, we do for the D actually. So when you say D, so D should be here. D, not F. So the D. D is direct runoff. Okay. Alright. So in that case, we have to change this because it doesn't look nice because its value is 300, but it is 50. So we can change to, let's say, 500. Okay. So now this is the hydrograph, and this is the unit hydrograph. Then we can combine it. Okay, we can combine it. So this one is not this one. This should be for based on the D. Okay, it should be the D. Okay, the D here again we have to change to 400, and this is the unit hydrograph. Okay, this is how we can. Okay. So after derivation, we can plot T versus others. Okay. So this is the unit hydrograph all about. But now, what you can do, I have a different application. Later I will show you. But this problem is just unit hydrograph. So now, let's say if I change to here, observation time is not 1 hour. Let's say 2 hours. Okay. Sorry. One more thing that I need to show you. So after plotting, we need to show because this is the 3-hour unit hydrograph. So this is the 3 hour. How to show the 3 hours? This is the 1, 2, 3. So until this. Okay. So meaning that, so I cannot write here. So until 3 hours, we have to means this is the 3 hours. And this is the 3 hours. This is the 3 hours. So here, okay, I will show. I have already explained in the PowerPoint how to show. So 3 hours you have to take from here, and you have to draw here. Just draw by a text box or manually. Maybe I can show like this. Let's say I can draw a text box. I bring here. So 3 hours. Like this. So now I just put the color. So this is the 3 hours. This is called 3 hours stream flow and 3 hours unit hydrograph. Okay, but never write 1 hour unit hydrograph because this rainfall is 3 hours, so it is 3 hours. Okay, right? But these are things. After this, we can convert to different different unit hydrograph for different amount of rainfall. Means stream flow for different stream. Once we have the unit hydrograph, we can generate the stream flow for different amount of rainfall. Okay, so that is this column 6 and this one. So we will come this one later. So now I just want to show you here. Let's say if we change to 2 hours here. 2. So 2. So now is every 2 hours. So when it is every 2 hours, so now you can see my time duration already changed. Okay, here 2 hours, and then my effective rainfall is not as before. It was before 1 point something. Now it is based on this value, so it is 2.25. So now our unit hydrograph ordinate, you can see here, this is the director now. So this one is this value divided by this value. So automatic calculated, okay, in the sheet. So everything is correct. This one is checking this one is correct. Okay, okay. And then my stream flow and unit hydrograph is like this. But it is still 3 hour unit hydrograph. So you have to draw like this. But same data, if I change here just for here, if I write here 2, what will be done? This is 2 hours, this is 2 hours. So this data should be here 2 hours, not 3 hours. But we can change 3 hours later, not now. Okay, at this moment we just derive unit hydrograph for the same duration. So if duration is 2 hours, we produce the same duration unit hydrograph. But here it says 2. This means the same duration of rainfall, storm, and the observation time is the same. But this can be 3 hours, no problem. Every 3 hours. So when every 3 hours, you can see my time is 3 hours. 3 hours. Okay. But when you draw here, my rainfall is 2 hours now. Rainfall storm is 2 hours. So you have to show how here is 2 hours. This is the 2 hours hydrograph and 2 hours unit hydrograph. Okay. So maybe this one need to extend because it is 36. So we can. Maybe here you can put 5 and here put maybe 4. Okay, 2. So here rainfall duration is 2 hours. So now it is 4. So you have to put this is the 2 hours. Okay, so this plot, once you after deriving the unit hydrograph, once you plot it, then this plot tells you what is this. This plot tells you this is the 2 hours. You can see the time 2 hours. So you have to write here. So you have to go to the here. You have to edit this one because this is 2 hours now. You have to write here 2. Anyway, so you can not change because something here you have to change first because I selected from here, so it just changed 2 hours here. Now you can change it. select data to our unit hydrograph. Alright, so this changes. So this means that this is the 2-hour unit hydrograph produced from the 2-hour storm that was observed every 3 hours. Okay, so this is the explanation. I hope it is clear, everyone. So please practice, try to understand. After this, if you have any question, please ask me in the class. Okay, so this is the things. So next, I will show you what is the application of unit hydrograph. Means once we have the unit hydrograph, what is the benefit? Once we have the unit hydrograph, one is the simple application I have shown here. You can generate the stream flow, because when you study the hydrology, actually we need the stream flow, not the unit hydrograph. Unit hydrograph for 1 centimeter, but in the watershed we can have a rainfall for 20 centimeter. If rainfall for 20 centimeter, like, so what will happen? 20 centimeters. So meaning that once we have the unit hydrograph coordinate, just multiply by 20. Then we can see what is the stream flow. So this is the amount of stream flow we will generate in the watershed for that particular rainfall event. If rainfall is 20 means 200 millimeter huge, so we consider as a flood, is it? So then we can see we can give the warning flood is coming. So this is the another approach. We can use the rational method, we can use maximum, we can use the stream flow frequency analysis. This is the another approach. When we don't have this long time data, but we have a short time data, or we can observe this data, then once we observe this data for short time, this T and Q, and if we delineate the watershed, then we can derive the unit hydrograph. This is the another simple approach, but very effective approach. Okay, thank you very much. I like to stop now.